Jing, got it. Okay, and Binyuan and Jin, you are here. Great. So let's wait for 1 or 2 minutes before people pump up.
Well,
So a few really exciting things going on. One is I had the opportunity to join the panel discussion today at the Brown School in the faculty retreat together with Professor Patrick and Mark Lowe, Vice Provost in the School of Medicine. And we had a fantastic conversation among Brown School faculties. And the panel discussion is 1.5 hour long, but filled with questions. So there were so many comments and questions from the faculty, and reflecting the invasiveness and applications and confusions and frustrations raised by AI. So the popularity of this topic, I would say, is just the beginning. So we'll have a lot of more conversations on campus regarding the ethical, responsible use of AI, the innovative of AI applications in different domains. So stay tuned, and you will see probably various policy recommendations and workshops provided by the central campus. Some through the Centers for Teaching and Learning, some at the school level, and some other policies at the provost and chancellor level. So a lot of ongoing efforts just to try to wrap our mind to see what are the ramifications of AI and how we are going to ride by the wave and also try to avoid the pitfalls. Okay? So a very interesting development. Okay, so I know, yeah, this is a kind of a confusing to some of you. You may not be able to attend because we changed the time, and it's completely my fault. Because tomorrow I have a get together I have to attend. So I ask Yu and Charles to change the time from Saturday to Friday, just for this single occasion. So later on, we still stick to every other Saturday evening at 7 p.m. So this is an exception, and I do apologize if the time is not convenient to some of you. And I guess people have to go through the recordings to accept my apologies. So, and you are still in Chicago, or you come back to campus?
I'm still in Chicago.
Okay, great. Are you coming back tonight or tomorrow?
And I'll coming back tomorrow night.
Tomorrow evening. Okay, yeah. Just drive safe. Chicago, well, in general, is not a safe place, unfortunately. So yeah, definitely stay safe and drive safe. Okay. So the new semester is around the corner. So I want to say that our team, our AI interest group, is going strong, and it's going to be probably going stronger starting from the new semester. There were new initiatives there. I see quite a number of potential opportunities. So recently, I was contacted by the Vice Provost, Jan Smith, and who is interested in providing workshop seminars at the campus level to both faculty and the students. And my recommendation is that we need graduate students. We don't want faculty to talk about their boring research. we want graduate students like you guys who are energetic, who accept new information, absorb new technology faster, to be at the front line. So there could be potential opportunities open up for many of you actually to be at the center stage and deliver maybe workshops, seminars, talks, and educate our faculty member. There could be other opportunities in research as well. So there are various centers, center directors that are interested in our students to look at their data because they have collected over the years many private data sets that are underutilized. And they have really exciting data set, big scale data set, Medicaid, Medicare, also housing, no longitudinal health surveys, etc. Right? So but they don't have the expertise to look at those data, to explore and interrogate the data. Of course, they want to use the state-of-the-art AI technologies, right? So many interesting and potential ways for us to engage. So I would say, yeah, I don't think there's an even better time, ever better time than now to be engaged in the artificial intelligence. Okay, so I think I have talked enough, and so today, we ask Charles, who is a doctoral student at DCDS in computational data sciences, and I asked Charles to prepare a presentation on LlamaIndex. So there are now so many startups and so many new technologies that are wrappers around different large language models and computer vision models as well, right? So the reason why I intentionally choose some of them, one is, of course, we can't cover them all, right? We can't even cover 1/100th of them. But the second is my vision and perspective is that we should be looking at the general technologies that are model agnostic. So it means that one particular model, for example, ChatGPT today, could be some other models could take place of ChatGPT to become number one. Other models most of the model, I would say, would not be used and would become obsolete very soon, right? So what we want to look at are the technologies that are more of a platform. Basically, thinking about if each model is a fish, we are not looking at individual fish because it's just so hard for us to predict what's going to happen with this fish, right? That fish may live 100 years or may die in the next minute, right? So, but if we look at the pond, basically the platform that hosts those fish, then the pond is going to be there for quite some time. Well, of course, the pond can be replaced as well, but it's harder, right? Because the pond, for example, Hugging Face is a pond, right? PyCon is a pond, LlamaIndex is a pond. So those ponds are model agnostic, meaning that they host many models in the same platform. So one model maybe get out of the fashion, but there are other models who are going to take their place, right? So it's much safer and stable to look at the ponds than individual model development. So that is my personal intake. And why I ask Charles and others to specifically looking at those platforms that host and integrate and standardize those large language models and other models. So without further ado, let's welcome Charles to give us his talk on LlamaIndex.
Okay, thank you very much, Professor An. Let me just pull up my screen and okay, can you guys see it? Yep, all right. It's just to clarify, it's a PowerPoint, right, that you guys are seeing, not all Google Slides, not something else, right? Yeah, okay, awesome. So today my talk is how to ingest and query your own data to LLMs, large language models, through LlamaIndex. Okay, so let's get started. So this is kind of the problem statement, right? Firstly, you have your own data here. You have a large language model, right? You want to ingest your information to the large language models such that you can query. Query means, ask questions with regards to your own data to the large language models, right? How do you do this, right? One very common way is fine tuning, right? Where basically you have all these weights from a large language model, and some people say you adjust or reweigh the weights, but I like to see it as, like turning a doorknob, right, on a radio. You are just making adjustments, right, like turning a doorknob on the radio, a knob on the radio. You're adjusting the weights based on the data you feed into the large language model, right? So it's more accustomed to your data now. Well, the problem is that, firstly, it's very time consuming, it's resource intensive, and it's also very computationally costly. And it's also very opaque in terms of the transformations, right? So sure, you get to monitor its loss throughout the whole fine-tuning process, but beyond that, you don't really know exactly which weights are adjusted or what's going on or why is a particular weight adjusted, for example. Yeah, so it's also very opaque in its transformations, right? Another one that we have extensively talked about is prompting, right? So obviously you prompt the large language model so that it could improve in relation to the data you provided. Well, there's also another problem, right? Which has a limited token limit, right? Less fine-grained control, right? And it can be an overhead for users, right? So you need to experiment with various prompts to get the desired output, which can be time-consuming and require expertise in framing questions, right? So bear in mind, we're dealing with extensive documents here. We're not just dealing with, and later I'll throw examples of it. We're dealing with extensive and heavy documents. We are not just dealing with, a short piece of paragraph, for example, right? And also another thing is that, we are dealing with unstructured data, which is in some form of text. Text data is unstructured. But nowadays, many of our data comes in different forms. We have PDF, we have the tabular data from CSV files, we have videos, we have audios, you have images, right? How do you ingest these data into the large language models and such that you can query your data, right? Because sure, I mean, they're not text in nature, right? But they contain textual information. You want to be able to extract this text information, feed them or ingest them into the large language model such that you can now query it over your data. So that's an additional dimension of challenge, right, towards large language models, right? So far, it's only limited to whatever you feed them, and it must, in some sense, the data must come in a pretty structured format, right? And that's kind of when LlamaIndex comes in, right? So basically what happens is that you have all these heterogeneous data, images, audios, PDFs, CSVs, videos, right? You inject it in through to the large language, and later I'll demonstrate exactly what I mean, right? LlamaIndex allows you to inject it, specify your large language model of choice, right? It stores it in a vector database, and now you can query that data. The best thing of them all, in my opinion, right, is that you can even do a combination of all of these. And later I'll show you how to actually do it. Right, so the idea is that, again, you have a knowledge base, you have relevant context, you want to inject it into the large language models. Right, now with your own data injected in, you can query the large language models and get a response, which now has the relevant information injected, the relevant information from your own data, your own personal data injected into that large language model, right? So essentially can be divided into two stages, right? The indexing stage, right? When they index your data into a knowledge database, and the querying stage, right? Which retrieves the data based on what you ask of it right, after you've injected the information. So during the indexing stage, right, you have a data source. So it's your PDFs, your videos, your can be structured data, right? You inject it into the data loader. Oh, sorry, the data loader loads documents and it indexes it into a knowledge base. Through this knowledge base, now that when you query it, right, it retrieves it, right, through a node post processor, right, it synthesizes the response, right, and it gives you the query, right, and from there you can even build a chat engine, for example, right. So this is the querying stage, right, which happens after that.
So Charles, sorry, could you go back and because some of the audience may not be familiar with the just go back to the previous page, not this one. You go forward. Yeah, keep going. And keep going. Yeah, keep going. Yeah, it's this one. So some of the audience may not be familiar with, for example, what is the function of retriever, what is node, how do we define node, and processor, why we need to process the node, and also what is the response synthesizer, and also the end functions, right? The query, chat engine, agent, how they are different. If you could speak a little more about, explain a little more about those concepts.
Yeah, actually later I'll give some examples and we could yeah, and I'll explain it more in detail later. But thank you for
great, sure.
So in short, LlamaIndex is not a new pre-trained large language model, right? It's not like a new GPT model. It's not Llama. It's not BERT, right? It is none of that, and neither is a new vector database storage system. Right? Rather, it's a bridge, right, between your data with an LLM or vector storage and a platform for you to perform queries, right, from your own data that has been ingested into the large language model, right? So you can think of it as like a tour company, right? For example, right? A tour company arranges the flights for you, they arrange the accommodation for you, they arrange the transport for you, and they bring you around the sites as long as you just book it through them, right? The flights already exist, right? It's through a separate airline. It's from the hotels are a separate brand. Maybe even the transport is a separate brand, right? And it's the same here, right? So there are all these models, there are all these large language models, there are all these storage systems, right? LlamaIndex is basically like the tour company. They kind of piece it together for you and allow you to utilize all this, right? To ingest your data into the large language model. So, and this is when I'll explain more and perhaps you will get a better idea of what a retriever is, what a node is, and stuff like that to answer, which Professor An did ask just now, right? So this is so basically how they index your data, right? We're going to go through how they index your data and also how they query the data from these indexes, right? Yeah, I'll go through vector storage index, list index, tree index, and keyword table index, which are the four most common ones used in the LlamaIndex, right? So in the vector store index, you have nodes, right? So nodes are basically, you can kind of treat them as parts of it. Well, I mean, parts of a data which can be linked with each other, right? So within each node, right, based on the large language model you specify, it will embed the data, it will embed the text and store them in a node, right? So these are the nodes here, right? You break the documents down into nodes, right? And then it will insert the node into a vector database, right? And then during querying,
sorry, Charles. So I just want to make a comments for those who are not who have no knowledge on indexing at all. No, no, maybe you shouldn't be too young to have ever been walking into a physical library, or maybe you've never walked into a physical library. I don't know. But no, I would say no. Some of us are old enough to walk into a physical library. And how do you check out books, right? So you go to there are so many books into different stacks, into different places. You look into the indexing, right? First by maybe alphabetic number. You go there and then you dig into, maybe you go to the history section, and then the history section, it tells you is from A1 to A7, right? And then you go deeper into the specific section and looking at the book numbers, right? So you can think about the index is just a label using either numerical value or a series of alphabetic and numerical value to tell exactly where the book, here is where the data is stored. So that is the essence of indexing. So indexing make searching much easier than before, because otherwise you have to search entire library to find that single book, which is almost impossible. But now if the data are well sorted into indexes, then it's much easier for us to find the specific information from a huge bulk of data. So that's what I want to explain for those who don't know much about indexing, why we need indexes.
Yeah, thank you very much, Professor An. Yeah, that's a very good explanation. Yeah. Okay, so now we have this vector store index, right? How do we retrieve the information, you ask? So now that we have our documents, it's in this vector store index, right? How do we retrieve the information when we query it, right? So it goes through the query, right? And then for vector store index, throughout the nodes, right, which we have already broken down the documents into nodes, right? By default, they use similarity top k. So it has your query, right? It finds the query which responds to the most using cosine similarity, right? It responds to the top two most similar nodes through the embeddings, right? Through the embeddings of the query and the embeddings of the nodes, it finds the top two most similar nodes, and it gives from the top two most similar nodes. Now it gives the response, right, of your query. And again, you can change this to 3, 5, 10, or anything you like, right? It doesn't have to be 2, but by default it's 2. Is there any questions? I know it's a bit confusing, but is there any questions?
So yeah, I also want to add here, so what's the reason why we want to separate a document into different nodes? So for example, if we have one paragraph with 100 sentences, maybe we break them down into 50 nodes, right? Each node contains 2 sentences. So in this way, we can more precisely identify the exact content based on your query. And Charles just mentioned about the cosine similarity. You think that this is abstract, but well, everyone knows Pearson's correlation coefficient. So there is some mathematical equivalence between similarity, cosine similarity, and Pearson's correlation coefficient. Right. So it's not abstract. Actually, it's just a number, say from -1 to 1, denoting how similar that 2 items are related. Is positive or negative, and to what extent.
Yeah, thank you, Professor. I'm sorry I got ahead of myself there. Yeah, that's correct. Yeah. So the problem with and we'll go through the pros and cons of each indexing method, right? But so a vector store index, right? It's good if your query only requires a specific portion of your data and you want fast retrievals, right? It's bad if the importance of your data throughout the whole text is uniformly distributed. So a very good example is, for example, you have a book, right? On sometimes when they publish, for example, in the public health, and I'll show you an example later. for example, they publish the history of SNAP, right? Supplemental Nutrition Assistance Programs, right? And for example, it's divided into many chapters, right? You want to know how, for example, the 1977 Food Stamp Act, right? Why, for example, why was it introduced and what were the benefits of it, right? It's only a small portion of the entire book, right? This is when a vector store index would be very helpful, right? But if you want to query something very generic, right, like a summary of the book, for example, this may not be the best, right? Because it does not consider all aspects of it. So again, and I'll show it later, it's important, right, that you understand, at least when using LlamaIndex, it's important to understand what indexing type you should use based on the data you have. You can't just dump your data inside and just choose any storage index you like, right? You have to be very careful as to what you choose. And the second one that I'll go through is the list index, right? So we can think of it as a list, right? Inside the list, there are now different nodes, right, that are linked to each other in a uniform direction, right? So node 1 is linked to node 2, node 2 is linked to node 3, etc., right? So during querying, right, you can see you ask the list index query, or you ask the query, right, and then it has to retrieve information from the list index, right? So it goes through node 1 first, right? And then it feeds that, through, and then it traverses to node 2, and it traverses to node 3, and based on the accumulated information, right, it provides you with the response, right? As you can already see, it does not simply select based on the 3 nodes, unlike the previous example, right? Instead, is in some sense, it traverses through all the nodes. And that's when it's also a disadvantage, right? Because it's significantly slower, right? But it's also good if the text, the importance of your text is uniformly distributed, right, across your entire database, right? So that is when you want to use a list index. You want them to consider everything, and each section. For example, if it's a book, each section is important to my query. That's when you want to use a list index. So moving on to a tree index, right? It works almost identical to a decision tree, right? You have your root node, right, and parent nodes. Then from there, it's splitted, right, into further further leaves, right? Oh, sorry. Any questions about list index? My bad. Okay, I'm guessing it's none. Yeah. So okay, like I said, right, you can think of it as a decision tree where you have your root node, your parent node, and the child nodes here, right? So basically, during querying itself, right, by default, right, it takes a child branch factor of 1. So when you ask the query, right, it chooses the node, right, which is or the child node, which is most important to the query that you've asked it, right? You also can specify how many child branch factors you want. So for example, if it's 2, right, it would now the response, right, would from the query could consider more than just one child node. It can consider multiple child nodes now, right? And of course, this is good if your text is hierarchical in nature, right? But again, right, compared to the vector store index, which is the default of LlamaIndex, it's much slower in nature. And also another disadvantage, which I forgot to put here, is that in most cases, because unlike the list index, which is, you see, it's linked to each other, the nodes are linked to each other, here, right, for example, node 1 and node 2 and node 3 and node 4, right, they are independent, or at least they can be considered independent of each other. So if not only does it have to be hierarchical, but for example, different chapters, right, cannot be consistently referencing each other, right? Then the tree index may not be working very well. Is there any questions?
So I have a question.
Yeah.
To what extent LlamaIndex is smart enough to auto-select the indexes based on our query, or it is not possible?
You mean the type of index?
Yeah, so basically, do we need to pre-select an index, or based on our own inquiry, the LlamaIndex would be able to auto-select an optimal, hopefully optimal index for us?
Unfortunately, for now, we have to select our own. Yeah, which is which is why I mentioned earlier. You cannot just dump the data inside and randomly choose any of these index types, because you can sometimes, and I did get this when I was playing around with LlamaIndex. Sometimes if you choose the wrong index, you can get very crazy and dramatic results. So that's unfortunately a massive downside to LlamaIndex for now. Yeah.
Right. So we do need some background knowledge about the differences between those indexes for our selection.
That is correct. Yes.
Great.
Yeah. Okay. Now we have keyword table index. Sorry. Right. So basically, what happens is that, right, we already have the nodes, right, but now we have keywords, right? Keywords associated with the text that we have, right? So each keyword is now associated with the nodes, right? So in this case, right, for example, we can maybe, I don't know, we already have a vector store index, for example, right? This is typically built on top of the vector store index, for example, right? Where each key, you can say that each keyword is tagged to nodes, right? Right, and based on that, now that when you query the data, right, it tries to find keywords that are most relevant to your query, and from there, based on the tags, it will be able to tag itself, right, to the nodes, so that you can now get a faster and more accurate response. So in this example, probably the query was something like summarize the climate, right, of New York City for me, right? And they know that New York City is in node 1, maybe the climate, talking about climates, is in node 3, and from there they would know, okay, let me reference node 1, let me reference node 3, and I provide a response from this, right? And as you can imagine, right, this is good if your text is heavily keyword dependent. For example, in the scientific literature, right? It's also good for speed. Unfortunately, it's bad if the keywords are used in different contexts, right? Because, like I said, they just use keywords here and they don't really consider the context of keywords, which ironically is one of the advantages of large language models compared to most models, your classical TF, IDF bag of words, right? If you know that in your text, different keywords would be used throughout your whole data across different contexts, maybe you wouldn't want to use a keyword table index, right? And again, if the importance of your information is uniformly distributed across your data, you may want to think twice about using a keyword table index as well, right? So I'll provide use now. I mean, do you have any questions up to now? I know it's been very heavy and and very technical, but yeah, any questions?
Yeah, if the audience have any questions, because I believe that Charles made a great presentation so far and being very clear, but there are definitely a lot of technical terms and methodologies involved. So if you have any questions, just feel free to ask. no, for those of you who have not heard of, for example, bag of words or TF-IDF, so those are the previous traditional machine learning algorithm that we use to tackle natural language problems. For example, bag of words would be a number of keywords, but getting rid of all the stop words, meaning the words that are not that important, the fillers and the punctuations, and doesn't really consider the order of the words. Okay, we always know that the number of words is important, right? But for bag of words model, it's the simplicity really takes over, right? TF-IDF a little bit more complicated, but basically it's still based on the frequency where the keywords appeared in different documents, right? So those previous traditional machine learning models did not consider the context. So basically, it just uses the keywords to identify patterns, right? Without knowing the specific meaning of a word in a sentence. For example, they would be confused about apple as a fruit versus apple as a brand name, right? Because it doesn't really consider the context, right? Whereas now most of the natural language models are based on transformer architecture, and if you have learned about attention, basically attention is the way that we put word into context, right? We analyze the relationship between words from their neighbors, from other words, okay? So those are the context I provide to reference Charles' talk about the difference between the modern natural language processing models versus the rudimentary models.
Yes, thank you, Professor An. And yes, I'm sorry, I'm getting ahead of myself all the time. But yes, thank you, Professor An, for always filling up for me. Yeah, I think Professor An also gave a good example as to my criticism earlier, right? As keywords can be used in different contexts. So you can imagine if Apple is used as a brand name and as a fruit in your oops, sorry. Yeah, in throughout your text, right? But if you use this keyword table index, right, Apple may only appear once, and it may end up referencing the wrong node all the time. So I think it's yeah. Thank you, Professor An, for providing that good example. So yeah, I'll go through each of these examples, and I would provide demos for each of these examples. So for the demos, I try to make it very relevant to us. I think most of us are in some sense, public health researchers, if we can put it that way. So I try to use examples from that to give all these demos. I also try to use a diverse set of language models, both from OpenAI and Hugging Face as well, to demonstrate these examples. And yeah, so if any questions, please feel free to interrupt me and ask at any time. And if any of you are lost, right, you can always reference what I uploaded in the GitHub, in my GitHub. I'm sorry. It's there. Can you guys see the link in the chat? Yeah. So if you ever get lost, please feel free to reference what I have uploaded in the GitHub, and you can go by your own pace after this, and if you're still lost, please feel free to always shoot me an email and just ask me at any time. I'll be more than happy to help. So the first example, use example, right, is semantic search, where, of course, we query the data, but we are looking for specific searches, right, within the data, specific information within the data. You can kind of see it as performing a Google search, but this time, Google only has your data and not the data of the world. So that's an example of a semantic search, right? a summary, right, is pretty straightforward. You have a whole document and you want to compress it, right, into a few sentences based on, that summarization.
Oh, Charles, could you share your slide? We didn't see your slide. I'll talking through a slide.
Oh, I'm sorry. Yeah. Can you see it now?
Yeah, we can see
Okay.
your slide now.
Yeah,
Great.
yeah.
Yeah.
All right. Thank you so much. So back to what I was saying, semantic search, right? You can kind of treat it as a Google search, right? But, right, you just think of it as Google or Bing or whatever search engine, Yahoo. Yeah, you're performing a search on that, but the difference is that now it only has access to your own data, right? That's kind of like what semantic search is. A summary, like I said, right? You have all your documents, can be 1,000 pages, a few hundred pages, and you're trying to just get a few sentences or a short paragraph about what you want, right? That's another use case of LlamaIndex. And I know it looks like I'm just going through a list right now, but later I'll show you some examples. And so real life examples, not toy examples. So yeah. And then synthesis, another advantage is that, like I said, you can synthesize over heterogeneous data. So you can use a PDF, you can have a video, and you can query information from both the PDF and the video, right? That's one thing to do now, right? So now with the synthesis, some of you may ask, right? Okay, I have PDFs. It's stored in its own vector storage system. Videos, it's stored in its own vector storage system in its own nodes. How do they link the both of them together, right? And that's when composability comes in. So for example, you have 3 documents now. Each document has its own nodes, right? What composability does is that it tries to link, right, document 1 with or the vector storage of document 1 with document 2 with document 3, right? And now because of that, you can query it as if it's an entirely new document, 3 documents combined into one, and that 3 documents is one mega document. You can think of it that way, right? So any questions till now before I start my demo?
So just to clarify, when you talk about query over multiple documents, so do you mean the documents have to be the same type, or they can be heterogeneous in type? Maybe one document is a PDF, the other one is a video recording.
Yes, it can be the same, but it can be the different as well. And I would show, and that's what actually I'm going to do next.
Fantastic.
All right. So we're going to first go through a vector storage example. And this is a real life scenario. So here I have 3 PDF documents, right? Okay, why is it lagging? Okay, I'm sorry. So in my folder data, right, I have 3 documents. I'm sorry, the internet is slow. Yes, okay. Can you guys see it? The documents? Yep. So I have this first document, which is a PDF report / publication. You can see it's 32 pages long. The second one also is 32 pages long, but it's about the same thing. It's about food insecurity and SNAP. And the third one is 28 pages long, right? Also another document, but this time by the USDA, if about food insecurity and SNAP, right? So in total, 32 plus 32 plus 28, that's around 64 plus, I don't know, close to 90 pages, around there, 90, 92 pages, 92 pages. So I'm not going to read through all of them, right? And also, I have a second data type, right, which is a video about SNAP about supplementary nutrition assistance program, SNAP, and it is 53 minutes long, right? So I don't really want to watch the whole thing, and neither do I want to read the 90 pages worth of documents, right? So this is when you would want to use LlamaIndex, right? So let me just run the code. So the first is pretty standard. You just set everything up in Colab like you usually do. Okay, read the relevant libraries, set your OpenAI key. I would highly recommend setting, even if you do not want to use, let's say you want to use a Hugging Face model and you do not want to use an OpenAI model. I would still highly encourage you to just maybe, you don't have to put your OpenAI key, but just put some random text here, because for some reason, LlamaIndex likes to throw errors if you do not provide the OpenAI key. So you can just provide anything you like. And loading the document is very easy. You just use a simple directory reader here, and you load it from your data. You do not have to specify if it's a PDF, it's a video. You just load it in here, and it will load the documents for you. So compared to most of the tutorials, I'm trying to go do a bit differently. This time I would be using a Hugging Face model, specifically the Mosaic MPT-7B model, to query over my data. By default, they would use, I think by default, they use the GPT-3 Text DaVinci 003 model. So we try to do it a bit differently, right? And then again,
Charles, sorry, just a quick question. So when you load the data, do you have to specify where the data are stored?
yeah. So in my case, I'm storing it in the folder called data. So you just provide the folder
it's
name.
called the data. Yeah. Okay, yeah, I was confused. I thought it was data refers to something else. Okay, it's just the name of the folder. Okay.
That is correct. Yeah. Okay. Yeah. Thank you for the question. And for me, I'm using the Chroma database, right? But in reality, you could use any of them, any of the databases here. They have a pretty extensive documentation. So if you want to use it, you can use it. Like, for example, I cannot remember, but I know someone gave a presentation about Pinecone. Yeah, you can use Pinecone. It's very simple. They provide tutorials, so you just need to copy and paste. Pretty much, that's it. So for me, I'm just using ChromaDB.
So because as you mentioned that LlamaIndex is not actually providing the vectorization, but through a third vendor, for example, PyTorch or Chroma. And here is a demonstration that actually the LlamaIndex called for other vendors to provide the vector storage. Is that correct?
That is correct, yes.
Okay, fantastic.
And I forgot to mention, but just now we read the data, and now we're at the indexing stage. So if you remember earlier, I said we can divide into two stages. One is the indexing stage, and one is the querying stage. So now we're at the indexing stage, right? And within the indexing stage, you can divide it into two further stages, right? One is the service context, and the service context is basically the LLM of choice, the large language model of choice that you want to use, and the storage context, right, which is the vector database that we are going to use, right? So as you can see, these are the two very important things that, I'm sorry, my computer is lagging. These are the two very important things that consist of LlamaIndex. Now that we have already defined them, right, we just have to change them from the defaults using this, right? And then now we define the index. And now we can move on to the querying, right? So the first query I want to ask from the
sorry, Charles. Sorry for could you explain a little more about? I think people have potentially have some questions regarding how you call the Hugging Face model, what those parameters mean. For example, people may not know what is temperature, why we set temperature to 0.2, and maybe what is torch float 16. They are a bit technical, but if you could give like a brief intro to those parameters to help people who haven't learned much about the hyperparameters for large language models.
Yeah, sure. Thank you so much. So temperature is usually how dependent or how deterministic you want your model to be. So if I'm not mistaken, 1 means deterministic and 0 means random, right? So do sample false. That means we're not sampling over the potential outputs of the large language models, right? So the tokenizer name and the model name is usually the same, right? I mean, yeah, you can call a different one, but basically tokenizer, right, is so tokenization is the idea being that you have a huge series of text and you want to map the text from your data to the text within the tokens, as what they call it, within the large language models, right? So you want to deploy it. So of course, in this case, we're using the tokenizers of this large language model that we have called, and the model name is obviously the model name. And the max new tokens, right, is the cap as to the amount of tokens, new tokens that we want to have. The context window is the window in terms of it's the window of context that we want to limit our model to, right? So plus minus 3,000 tokens, of which it will consider the context of the text that it's currently traversing through. And so model quarks, this line is not necessary, but it's just to basically reduce memory usage here. And yeah, I think
that's fantastic. That's fantastic, yeah. Charles. Just a minor correction that temperature, the lower temperature, the more deterministic the model is.
Yeah.
So 0.2, usually if you want to do scientific investigation, you set temperature to 0 because you don't want model to go wild and provide some random responses. But randomness corresponds to creativity. Think about the poem, right? Now how we creatively use a word in a different context provide the innovation, right? So if you want to write a poem, you set the temperature to a high value, usually 0.5 or higher. So so here, while we are inquiring the data, so we don't want the temperature to be high, so we set it to be 0.2, or feel free to set to 0 if you want to be quite deterministic.
Yep. Yep. Any other questions?
Yeah, I have a question.
Yep.
So, you use the PDF data. So if we also want to put like the video data into like making it tokenization of the words, that in this step we need to introduce other models.
You can so data so here is later when I introduce the video component of it, which I did mention earlier. You can, and as you can see, I wrote here service context equals to service context. So I'm just recycling the same large language model that I previously defined, which is over here. But you are free to go on and define a new large language model, of which then you can use to index the data. But yeah, so the short answer is it's up to you, right? For what I did is I just recycled the same parameters and the same large language model, but you are free to go ahead and use a different large language model. Does that answer your question, Yui?
Yes, thank you.
Yeah.
Charles, I had a question. If you have like multiple videos and documents, then would we need to repeat this step like multiple times, or the time or the number of documents we have, or is there any way like to have just one model and like repeat the process again and again, and we don't have to code for that? I mean, yeah, what would you recommend?
Yeah, so if you have, I mean, it depends on the data. The short and lazy answer is it depends. But generally, right, like for example, in this data, oops, let's see the two. You can see in data, I have 3 PDF documents all combined into one. And as you can see, the title is more or less the same. So if you can combine them into one folder and read them together and index them together, but that assumes that probably your data is heterogeneous, homogeneous, and so you don't end up confusing. You don't end up confusing the model when you're trying to query it. But of course now, because the video is somewhat different in terms of content, especially including and as well as the data type, but the content as well, then obviously I stored it in a different folder, and therefore I read it in a different. I indexed it separately in comparison to the PDF documents that I had. Does that answer your question?
Yeah. So it's like if you have like 5 different types of data, like in video, in doc, in Excel, like or in MP4, then you need to uh, repeat that process again for like MP4 differently, for PDF and for video, right? Like 3 times.
Yes, that is the recommendation. But like I said, you can even put them in one folder together and just read them all at once. But if you do that, you have to make sure that your data is homogeneous in the sense whereby it's all talking about the same topics. It's treated as one. And therefore, because if not, you will confuse the indexing process, and the model would read it as one whole document of similar contents or affiliated contents, right? We don't want to do that. Yeah.
Okay. So Charles, if there is heterogeneous data, like you have stored like all the videos in a separate folder and all the PDFs in a separate folder. If I have like one PDF and a video, so I would have to store them like in different folders, or I can do it in just a single folder and then ask my model to read that folder, right?
Yes, you can store that in the same folder.
Yeah.
But you have to make sure that obviously the contents are affiliated to each other, and they're similar, and they do not have any conflicting information as well. Because like I said, when they index it, they'll index it as one mega document, and now the mega document is assumed to be affiliated to both of that this mega document with sub documents are now assumed to be affiliated with each other. Does that answer your question?
Yeah. Sure.
Yeah.
Thank you.
Yeah. I think the safest bet is always just to have different folders. I mean,
okay.
Yeah.
Right, and Shabami, I think you mentioned a great point that usually we need to make some judgment calls. For example, we don't want one folder to contain 2 books, one on the apple as a fruit, the other one on apple as the brand name, right? Because that's going to only confuse the model when we do the indexing and data retrieval.
Okay, thank you, Professor.
All right. Any other questions?
I have a question.
Yeah.
When we put in multiple files like PDFs, what the output would be like? Would it answer my question like one by one, like answer the same question in the first file and then the second file, or it would be an organized, already organized answer?
It would be the already organized answer.
Okay. Or if it's a default, can it like give me the respective answer if I give him another comment?
Sorry, could you elaborate on the question a bit?
Yeah, I'm sorry. I mean, if I add some comments, would it give me the respective answers?
I believe if I understand your question correctly, the answer is yes.
Okay.
Yeah. So I think that is kind of when we, well, let me demonstrate first, and then we could see if that answers your question.
Okay.
How does that sound? All right, yeah. So my first question, right, that I asked, these documents, these are just a PDF for now. What are potential factors that could worsen food security due to SNAP enrollment, right? And then it went through all the documents, and then now it tells me, so it gives me the answer: self-selection by food needy households in the program, the program's limited duration, the limited amount of food assistance, limited eligibility, limited access to food, right? Limited availability of food, and limited distribution of food. And yeah, okay, these just end up becoming the same. But you can see, right, how I had just one specific question. I had over 90 pages of documents, and LlamaIndex, through my large language model, right, was able to give me a pretty decent answer of what I wanted based on what I wanted to ask it from the documents. And I also use this is using vector storage index. So any questions?
Does the order mean anything, like 1, 2, 3, 4, coming from different nodes or documents, or it's just like a generic ordering?
I think it's a generic ordering. I don't really know the answer to that. I've gotten very mixed responses, to be honest with you, when I tried playing around with it. So I cannot pinpoint a finger to it. Yeah.
Right. No worries. Yeah. I don't know either.
Yeah. All right.
I have another question. Do you know how many tokens it can deal with in one time?
I think that would ultimately depend on your model. So different models have different token limits. I think GPT is something like 296 or something like that. I cannot remember, but yeah, I think that will ultimately depend on the model that you deploy, right? And each model has its own token limits. So it really depends, yeah.
So at the step you introduce the OpenAI API key, is that only for understanding your query, but not to deal with any data?
Okay. Yeah, that's a good question. So I mean, later I'll use the OpenAI model, but for now, I could change my key to blah blah blah, and it would run just fine because I'm deploying this Mosaic ML MPT7B model. I'm deploying this model, so it would just work just fine. But like I said earlier, when dealing with LlamaIndex, I'm not sure why, and I found GitHub questions related to this without any direct answer. If you just don't provide an OpenAI key, it can be anything. You can just even provide a fake key if you want. But if you don't provide it, it always likes to throw errors. It keeps on telling you, please provide an OpenAI key and stuff like that. My very personal guess is that because this used to be called GPT index, and therefore they sign an agreement with OpenAI or something like that, that unless you provide an OpenAI key, then we're gonna, I don't know. But yeah, so the OpenAI key is just to make sure that it doesn't throw any ridiculous errors not relevant to it. You can change it to whatever you like. You can put blah blah blah. You can put whatever numbers you like. Yeah.
Okay, thank you.
Yeah. Any other questions? Okay, yeah. So the next one I would use is summarize the effect of SNAP benefits on food insecurity, right? And let's just run it and take some time, but
So just when we are waiting, you previously, I remember you talk about when doing summarization, the vector store may not be the best indexing I remember that you talked about other indexing method that potentially more well suited for summarization tasks.
Yes, that is correct. So now that's what we're going to do next. I have list index in another tab. So we're just going to kind of see how the answers differ from now.
Fantastic.
And that's my next thing that I was about to say, right? Is that you can kind of see, right? It just it's so we use a vector store index, and I'm asking summarize the effect of SNAP benefits towards food security, right? And it's giving me answers like medical hardship is, it tells me something about medical hardship, right? And right, about falling behind expenses on medical hardship, right? And financial hardship, right? And finally, they only answer my question here, right? It reduces the likelihood of food insecurity by 13 percentage points. And then it starts talking about financial well-being and right. Now because SNAP, right, subsidizes foods for low-income people, right? Now they have more money for expenses such as housing, utilities, and medical bills, right? And you can see, it does provide the answer. It does answer my question, but it's not very coherent in the answer, right? And that's because it's using a vector store index, right? But like it still does the job, and if that's what you want, you can go ahead and use it. But again, not the best, right? And again, now we synthesize over the heterogeneous data. So data2 is my file, which I have the video, right? Over here, I have the composable graph, which I showed earlier. It's here, right, where it tries to link two different data types together, right? So this is what I'm doing. I'm just combining them. You can think of it as combining them into one mega document, right? And I'm now performing the query, and I'm asking the exact same query, right? And while waiting for it to run, because it's a video and it's an hour long, so please be a bit patient on it. But while waiting for it to run, right, the expected answer, or at least when I ran it, it's exactly the same, right? As it will show up probably exactly the same as the previous one. And the reason for this is because it is trying to retrieve the nodes which are most similar, right? So obviously it will be the same, right? Because at least now with this mega document, they still think that these two nodes, of which outputs the answer, is the most similar to even when you were to combine with the video document. So yeah, just give it a while.
So it means that they are going to do that in a hierarchical order, first by the two index 1 and index 2 to choose one, and then further do the query on one of the chosen index. Is that the case?
Next one, index 2.
Yeah, because
yes, in this case, yes, because I chose a list index to compose both index 1 and index 2. As you can see, list index 1, index 2. So yes, in our case it does that, but that would highly be dependent on what type of method you use to compose the data. So if you use something else, obviously it will work differently. Yeah.
Right. So the list index is what is recommended when we use the composable graph.
That is correct. Yes.
Okay. Right.
Yeah, and I'm not sure why it's slower than when I first ran it, but let's just try to move on. So here
I have a question. For for the last step, you introduced the video data. So is that I'm curious how it work with this video data. Is that extract the transcript from the video?
That's a good question. So what happens? So okay, this MP3 file is now here, but what happens is that initially it was only the MP4 file without the MP3 file. It takes the audio, converts it to an MP3 file, stores the MP3 file in your folder, And from there, it gets the transcript from the MP3 file. Does that answer the question, Yui?
Yeah, thank you.
Yeah. So now it's running the response. Just give it a bit of time.
And I think she probably previously, if I understand you correctly, she asked a question about whether we would be able to tell, from the responses, which part of the response come from which document or node. It is possible.
Yes, exactly.
The answer would be I don't know if there's a function for that. Yeah, that's a short answer. I don't know. Because there's so many functions, so perhaps.
Right. No worries.
Yeah,
No worries. Yeah.
But yeah, all right. Okay, I'm really sorry. I'm not sure why it's taking longer than expected. But we can move on. Okay, finally, it's done. Okay, so as you can see, and as I hypothesized earlier, right, it is exactly the same output even after introducing the video, right? And the reason being is because they have determined, at least, right, from the composable graph that the first index, right, which is the PDF files, still has the most important information of them all. So therefore, it will output the response, which is the same. Yeah.
Right. A good question. Maybe later on you can test out if you only use the visual file. What the quality of the response would be.
Yeah, that's a good question. Yeah. Yeah. So moving on, now we have sub question query engine. All right, and I'll just actually let's do this first. All right. So now earlier I showed you. So earlier I showed you for vector store index. Right now we're gonna do a list index. Because the list index takes a lot of time, so I don't really have the luxury of doing 90-page PDF documents and a 1 hour long video to show, but I would still show a pretty decent example. Okay. Oops. So in the list index example, right, in data, I have a wiki description of the snap program, right? And in the second data set, oops, in the second data folder, right? This time instead of snap, so I have a short video. I think it's about maybe 5 minutes long. I don't know, 5 minutes long video on Snap, right? How long is it? Not sure how long is it. It's 6 minutes. All right. So okay, I'm just doing this just because, as I mentioned earlier, list index does take much longer, right? So if I read the data. So now we do the exact same thing. So like I said earlier, right? If you're not going to use the OpenAI model, you can just literally leave the key as blah blah blah. That's what I've done here. I'm doing it just so that it doesn't throw funny errors in front of me. And yeah, again, we use the ChromaDB client, and this time we asked the question, right? Why was Snap founded? Who did it intend to serve during its founding? Right? Okay, and because it's a list index, so it'll take a bit of time. So let us just we'll come back to that later, but I'll go through the other use examples for now. So we have can you guys see the slides? Yeah, okay.
Yes.
So we have the next examples that I'll be going through as well will include the sub question query engine, So what happens is that you have a very complex question, right? It can break the question into different sub-questions related to the question. And the good thing is that you can see behind the scenes, and I'll show you later, you can see behind the scenes how it's trying to divide itself into different questions. If you ask a very complex, long-winded question, right? So how it works is that first breaks the complex query into sub-questions for each relevant data source, and it gathers all the intermediate responses and synthesizes a final response, right? So, and then joint Q&A summary query engine is basically like how you interact with a chatbot. You can ask it multiple questions at sequentially after another with reference to a previous question, right? And multi-step query engine, right? It decomposes a complex query into sequential sub-questions, right? So for example, one good example is that if you ask what happened before, during, and after a specific policy, for example, right? What happens is that when it queries the question, you ask itself what happened before, and then it will output what happened before, what happened during itself, and what happened after itself. So it breaks it down. But the important thing is that it has to be sequential. So like I said, you have to understand the context of what you're asking before you deploy a multi-step query engine, right? So okay, I'm just gonna go through this while I'm not sure why it's throwing an error, but yeah. So the sub-question query engine, right? As you can see, all right. This time we load data 3, which is the same as what I showed you earlier, a Wikipedia description of Snap, right? And now you can see, right? I'm asking 3 separate questions, right? Into one complex question. How does Snap impact one's nutrition, economic, and health well-being, right? And if I run it, you can see it's dividing itself into 3 sub-questions, right? What's the nutritional impact of Snap? What's the economic impact of Snap? And what's the health impact of Snap, right? And if you print the response, you see it synthesizes the responses together. So Snap has a mixed impact on nutritional well-being. While studies have shown that Snap participants consume more whole fruit, their intake of dark green and orange vegetables decreases slightly. It's important to note that Snap does not have nutritional standard for purchasers, which some critics argue is a missed opportunity for public health advancement. In terms of economic well-being, Snap has a positive impact. It's considered counter-cyclical government assistance program, providing assistance to more low-income families during economic downturns, and Snap expenditures stimulate the economy and have a multiplier effect on GDP, generating economic activity. Right? Snap benefits also put more resources quickly into the hands of people who are more likely to spend it, benefiting both the economy and vulnerable individuals. Right? And then now it talks about the health impacts and how, how they have better health outcomes, right, as a result of Snap. Any questions? No? Okay, I'm guessing not. So now I'll go through a joint Q&A summary, right? And I'm basically interacting it like how I'm interacting with a chatbot, right? So I'm asking, can you give me a summary of the impacts of Snap, right? I'm asking this, and again, it will take a bit of time, but
so the joint summary query is more leaning towards asking a number of follow-up questions. Is that right?
Correct. That is correct, yes. So for example, in this, I asked just to provide me a summary of the impact of Snap, and it tells me, elevates hunger, improves nutrition by allowing participants to purchase a variety of food items, promoting healthier eating habits, and Snap stimulates the economy, and et cetera, right? And after that, I'm curious, okay, what are some, what are some proposals to restrict junk foods, right? Because they say here it allows them to purchase, promote healthier eating habits, right? So for example, if I'm curious, right, so I ask, what are proposals to restrict the purchase of junk foods, right? And they say, and now it answers my query, right? The proposals to restrict the purchase of junk foods have been periodically raised. However, these proposals have been rejected by Congress, et cetera, right? Some experts argue that it should be considered as proposals to encourage healthy eating. So again, right, it's like interacting with ChatGPT. And now I have multi-step query engine, right? And I'm going to ask them a question, right? Okay, first we run the model, right? So you can see, right, I have 3 sequential steps. What are the immediate, what are the short-term, and what are the long-term impacts of the 1977 Food Stamp Act, right? And then we're just going to run it again. And you can see, right, it does break it down into 3 sequential questions, right? So the immediate impact is that it was made easier for low-income households to access food assistance, right? In the short term, the act increased the number of households receiving SNAP benefits and improved access to nutritional food. And in long term, right, during the early life, it found lead to a positive health and economic outcomes, including lower incidence of metabolic syndrome, self-sufficiency, and high school graduation rates. So you can see in the multi-step query engine, it was able to identify, right, 3 separate time-based questions, and it now answers it sequentially, right? So any questions? All right. Like this. Run all again. Hopefully it doesn't throw an error this time. Now we can compare the list index, right, with the vector store index, right? So like I showed you some documents earlier, and again, this time we just deploy a different model from Hugging Face just to try it out a bit, right? And the first question I asked was, why was SNAP founded and who do they intend to serve during its funding, right? And that's this is an example of semantic search, right? The next question I ask is, summarize the goals of SNAP for me, right? And again, this time I'll ask this question, summarize the goals of SNAP, but I would bring in the video, right? And this time you compare, if you use a list index, how does it differ compared to using a vector store index, right? So let's just give it time to run. So any questions till now?
So while you're running the model, do you observe a potential quality of response increase when you use open AI models versus the open source models in Hugging Face?
Yeah, the open AI models typically are better, but maybe that's also my fault because I mean, sure, 12 billion is big, but it's not as big as some of the models in OpenAI. So I'm using much smaller models, but I didn't want to pay for the tokens, so I just used yeah.
Right. Another question is, would LlamaIndex be able to provide us with some example questions based on the data that we provide to help us get started?
The short answer to that is I don't know because I didn't try. So I don't know, but that's a good question. Yeah,
no worries. Yeah, no worries.
Yeah.
I think it's because in the class we talk about Haystack, which is a data retrieval tool that actually can come up with questions from the documents. So I was wondering whether they have similar capacity.
Yeah, I don't know the answer to that. I apologize.
No worry at all. Yeah, no one knows at all. Yeah, it's all fantastic. Yeah, I learned so much from it.
Okay, so while waiting for them to generate sorry, was somebody else asking a question?
I had a question. It's like the summary QA query engine is working like a generative QA, right? Or is it different?
Well, all of them are generative QAs, but the difference between summary is that now, we're asking them to provide a summary. You're not asking them to provide us specific information. As a matter of fact, that's a very interesting question that you brought up, because let's say I use simple summarize here, but if I were to actually ask it a question, it would throw a lot of out of context answers for me. So again, it's important to know the context of what you're asking the question. Yeah.
Okay, thank you.
Yeah. And yeah, this will take a while because it's a list index, but I can go on to the rest, and hopefully when I come back, it doesn't have another error thrown. So, okay, another application would be compare and contrast, which I would also go through again later, right? Where you have two documents. I think that was what Shavani was asking earlier, right? Like, how do I know what to put in what folders, right? So let's say, for example, you have two separate documents, for example, a description of Snap and a description of another program, which I will show you as an example later, right? Then you want to put them in two separate folders and you want to perform a compare and contrast, right? So that's also another thing that you could do with LlamaIndex. And finally, you could also query over structured data, right? So you have your CSV files, you have your pandas files, you have your SQL data, and you can even query over structured data, which is what I would hope to show you if, yeah. Okay, so this is the first question that I asked. Why was Snap founded? Who did it intend to serve during its founding, right? So it's a government program that provides food purchasing assistance to people to help, adequate nutrition and health, right? It's administered by the USDA through benefits that are distributed by specific departments of state, right? It supplied roughly 40 million Americans in 2018 with an expenditure of 51.7 billion, right? Approximately 9.2% of American households have benefited, in 2017, and beneficiaries and costs increased sharply during the Great Recession. And, it provides a pretty comprehensive answer. And I think it's also pretty well structured in terms of the text. Just for a note, these are just the citations that come with the text, so it's not something random that was produced, right? And then now that the summarization summarize the goals of Snap for me, right? It provides food purchasing assistance to low and no income people to help them maintain adequate nutrition health, right? It's administered through the FNS, through benefits which are distributed by specific US states, right? It supplied roughly benefits to 40 million Americans in 2018 with an expenditure of 57 billion, right? And it keeps on going on, right, about the summaries of Snap, but you can see it's way more coherent now, right, compared to the vector index, right? And now this is when I'm trying to demonstrate that, you see, we have used list index throughout the whole time now, right? Previously, we got the same answer, right? Because the model identifies that, hey, these two nodes are still the most similar to the query, so they're just going to spit out the same two nodes, right? But now with a list index, because it checks through everything, you can see it provides pretty much a drastically different answer, right? SNAP is a federal program that provides food assistance to low-income individuals and families, authorized by the FNS and certified, right? Authorities certify them. In some states, SNAP has a different name, which was mentioned in the video, and it goes through, for example, CalFresh in California, Food Share in Wisconsin, and food stamps in New York, right? And it starts talking about electronic benefits transfer, which was talked about in the video, but was not talked about in the Wikipedia description, right? And it starts talking about being store approved, et cetera, right? And any questions? None yet. Okay, so I mean, we can see the difference now, right, as to how sometimes selecting a specific method would actually impact your answers and the quality of your answers. So now I would go through compare and contrast.
So sorry, before Charles continues, I just want to mention that we are at the top of the hour. So it's 8:30 in St. Louis time. So if you have something else to do, and I completely understand, so feel free to log off. But we have the video recordings that we are going to share with you later in case you want to check the other excellent materials Charles is going to offer. So I'm going to stay here, but feel free to go if you have other responsibilities.
Yeah, I just want to add to Professor An that I would not delete the GitHub repo, so you can always just look through the codes yourself in my GitHub repo. I think I provided the link in the chat. So yeah, okay, but moving on, now doing compare and contrast, right? So we have been talking about Snap the whole time. So now, for example, and I'm doing this in a TXT file just to save us a bit of time, even though I still ran over time. But in my first, oops, yeah, I'm sorry, it's a pretty big file. In data one right now, I have a description of Snap, the Snap program we've been talking about the whole time, right? In data two, I have TFUP. I'm sorry, I cannot remember the name off the back of my head, but it's something about emergency food assistance. And it's also a program which is similar to Snap. And in data 3, right, I also have another program. It's called the Farmer Market Nutrition Program, right? It's also something adjacent to Snap and TFUP, right? And I'm going to challenge the LlamaIndex by getting it to compare for me, right? What are the differences between these programs, right? And here is also when I demonstrate the use of a keyword index. So as you can see, I have done the same thing. I've defined the vector store. I've defined the LLM, which I use. I chose another different LLM, right? And then I built a keyword table index, right, on top of vector store index, right? And the first question I ask, right, is compare and contrast the different recipient targets between SNAP, TFUP, and FNMP, right? And this is without using the keyword table index, right? So it tells me SNAP is for low-income households, TFUP is low-income seniors, FNMP is for low-income women, children, and seniors. So the answer, right? And then it tells me the first two are the same, but the third is different. The first two are the same because they're both targeted at low-income households. The third is different because it's targeted at low-income women, children, and seniors, right? And this is without using the keyword table index, right? So now let's see how it differs if I were to use the keyword table index.
Could you show you saved the files, the 3 files into 3 different folders, right?
Yeah.
What function you use to concatenate those folders?
I use this is when the simple keyword table index is used.
Oh, okay, I see. So basically, go through the folders. Okay.
Yeah.
Great.
So actually, for this one, I think this one I used a vector store index, which is just query engine, and then for this one, query engine decompose, I used a keyword table index. I think the idea I'm trying to show is that I'm trying to compare the answers if we were to use a keyboard. But yeah, you can see now if we use the keyword table index, it kind of gives a different answer. They're all federal programs that provide food assistance to low-income Americans. They're all designed to help low-income Americans gain access to food commodities in times of desperation. So you can kind of see how using a keyword table index does sometimes dilute your answer because it only extracts what it believes to be important from keywords, as compared to, say, here, which I used vector store index. It gives a very comprehensive comparison, right? Well, it just tells me, oh, they're all the same. It's all low-income Americans. right? And now I'm going to show you how to do with it at the structured data. So again, we just import our packages. So this, I got this data from the census. I think it's the 2020 census. And basically it's data on how many housing units are vacant in each county in the greater St. Louis city region, right? So as you can see, this should sound, I mean, I don't really live in St. Louis, but this should look familiar to a lot of you, right? So these are the vacant units, right? And now I'm just going to create, all this does here is it just creates an SQL structure for me, right? I'm just going to have three SQL keys, which is the county, the vacant unit rate, and the state, right? And the reason why state is because apparently in St. Louis, there's Illinois and Missouri. So yeah, and I'm going to ask it, right? So these are all tabular data, and I'm now going to ask it, which county has the highest vacant unit rate, right? And we're going to print it, and they say Kowloon County has the highest vacant unit rate with a rate of 19.76%. And it's true, right? Because if you look at it here, where is it? Kowloon County, yes, it's the highest, right? With 19%. So now, let's say, for example, I have my tabular data. I also have text data. I want to combine these two together, and I want to be able to retrieve information from both my text data and my tabular data. How do we do that? So what I'm doing here is that I'm just traversing through Wikipedia, right? And I'm trying to load the Wikipedia descriptions of each of these counties, right? Okay, so now it's downloaded all the Wikipedia data. And this is something which is not available in my tabular data, right? As you can see, I do not have the African American demographic here, but I'm trying to, but it's available on Wikipedia, right? So I'm trying to ask it now, which county has the highest African American demographic? And it tells me St. Clair County has the highest African American demographic. So you can see it's able to tell itself, right? You know, this is available in the text data, but it's not available in the structured data. And just to make sure that the model is not hallucinating, I'm just asking the same question, which is the highest vacant unit rate. And true enough, right, it gives me the same answer. Any questions?
So you use the SQL or SQL and provide construct the key so that each row of observation is unique. That help with the data extraction. Is that the case?
That is correct, yes. And
yeah, for those of you who are not familiar with SQL or SQL language, we need to provide a primary key so that we can be specific, specifically identify each unique rows. So that is the key here has a specific context meaning pertaining to SQL language.
Yes, thank you, Professor An, for doing that, for providing the explanation. And in the final demo, I would show you is now that I want to use this in pandas, right? So we have a similar data set, right? The vacant unit rate, but now I also have the population density. All this, you can get it through the census data, right? Again, of all the counties in the greater St. Louis area, right? So we store it in a pandas data frame, right? We index it with the default settings, and we perform the query. So now I want to know what is the correlation between the density and the correlation between the density and vacant unit rates, right, of all the counties in the greater St. Louis region. And as you can see, it's able to provide me with the code as well as with the figure itself, right? So now I want to ask it, for each county, what are the number of vacant units per population, right? Sort by highest to lowest, right? And I would ask it, and yep, it gives me the vacant unit rates per population, sorted from highest to lowest, right? So Kowloon County first, wow, followed by St. Louis City, and then Crawford County, so on and so forth. So, yep, that is my last demonstration. I'm sorry I ran a bit over time. But if any of you are lost, you can always refer to the GitHub repo that I provided. I will also send Yui the slides. So yeah, any questions?
I have one more question. So for the census data, because the data, I think the data don't have labels. So when you ask it a question, can it understand it correctly? Because for some like data sets, the variable name is not like very straightforward. We cannot like understand it if you like ask it about like the unit per population and county names, but the variable name maybe not. I'm not sure if you understand my question.
Is it like FIPS codes? Is that what you're referring to? Or
I mean the you use the census data and then you like ask the question about the information in the census data, and the question is based on, I feel it's based on the like the valuable name, but the valuable name sometimes it's not very straightforward to provide some information, because for most of the data set, I think we have labels for the valuable name. So
oh, you mean encoded labels? Is that
yes, yes. Without the labels, how it can understand like our questions?
The answer to that is I don't know because I did not try it. But yeah, I'm sorry, I don't know the answer to that. Yeah.
So if the we only have some variables and the variables don't have the variables don't have labels, I'm curious how the model like to summary the data set without like a theme for the image or for the PDF document or for like videos. I think it can give us a it has a topic, it has a theme, so it can have a summary. But for a table, I'm not sure.
Oh, okay. So you're asking it for like I don't know. Let's try, right? I think you're asking something like this. Well, it can, I guess, because is this what you were expecting? Where you're asking it a very you're rephrasing the question such that you're asking it like you're asking a document, but now we are querying it through the the data set. Is that what you're asking? Like, for
So
example, summarize the rule.
I guess Shanshan's question is more about if the data, if the structured data do not have specific names for counties, basically expressive names, but only a label, right? No, maybe a label named 123 A/B, then it's harder for the model to understand exactly what the question is and identify the counties. I guess this is a simple solution, though, because the table has to be expressive as well, right? Now we need to make sure that the table can be understood using the text, for example, meaningful variable names or row names. So it helps, right? Because the language model understand language, of course, much better than other context. Maybe the model will store the census tract number, so it's know where the census tract locate, but there's a long stretch, right? We want to make the model easier to understand your request. So I guess is that what you meant, Shanshan?
Yes. Is it possible like we have a CSV table and it doesn't have very clear labels or names of like each values, but we have like data dictionary, then can it use both the CSV file and the data dictionary? The dictionary can be a like PDF or Word document. Can it like maybe combine the two different documents? Then I'm not sure.
No, I don't think. I think the answer will be no. You have to clean the data up first before you feed it in, because, like I said, it assumes that each data is linked to each other. So, for example, you have a dictionary which says, I don't know, total population is within some code, for example, some encoded code from the census data. It may confuse itself as context rather than references. So yeah, I think the answer is that you have to clean up the data before you actually feed it in. Yeah.
Right. Yeah, actually, Shanshan raised a good question because a lot of data are constructed in a way that they have separate code book, right, to decipher, to provide definitions for each variable name. But the variable names are generic, right, using alphanumerical values, right. So yeah, I agree with Charles. I don't think we are at the stage that we can be confident that the model can do the right job by cross-referencing the code book with the variable name. I think it's still a long stretch. The model may be able to do that to some extent, but I think the risk, the stake is high there. I would say probably better approach to be expressive. Maybe in a year or two we can fix this problem. But now, yeah, I was kind of suspect that the model may not at the stage of identifying, make the perfect match, accurate match between codebook and the data.
I see. Thank you. Thank you, Dr. Han. Thank you, George.
Any questions?
I have a quick question. My question is about the engine. You mentioned many different engines with many different examples. So maybe you have already mentioned, but I lost it. So I want to ask, how do we choose those different engines based on our like question types or our data file types?
Sorry, when you mean engines, you mean the indexing types?
Yeah, engine.
You mean the indexing types, is it?
Yeah. You mentioned the engine, different engines in the indexed part, right?
Yeah. So like, you mean like list index, or vector storage index? Are we talking about that?
Yeah. I want to know the difference between them and how to select them.
Yeah, that's a good question, and the answer is that there is no straightforward answer. You have to select it based on the context of your data and based on the type of query that you're asking. So, for example, if you want to perform a summary of chapters of a book, for example, right, and each chapter has equally important information, then you would want to use a list index, for example, because it traverses through all the notes before it provides a final output. Where else, vector storage index will be the best because it uses top case similarity, right, from the notes, and it just spits out the notes based on the top case similarity. So unfortunately, there is no, I think Professor An did ask this question as well. There is no straightforward, maybe I won't be surprised if they do it in a few months' time, but for now, there is no function which could read your data and it could try to understand what's the best given your query.
Thank you so much.
Yeah.
Other questions for Charles? Okay, so really, Charles, thank you so much. You must spend hours, I would say probably even days, on preparing this very comprehensive and in-depth tutorial and workshop. And I believe that we all benefit so much. I learned tons from your presentation. So I took probably just 1.5 hours looking at LlamaIndex. I thought it was interesting, but then you really take the heavy lifting to go through line by line the code to demonstrate the capacity as well as limitations of LlamaIndex. So this is really, really fascinating. And I encourage all of you to think deeper about the difference between LlamaIndex and large language models. So think about what's really differ between inserting data into LlamaIndex versus providing a large number of tokens directly to feed into a large language model. For example, Anthropic now can take up to 200,000 tokens, right? So I have some intake, but may not be correct. Those I encourage all of you to think about it, the differences, the similarities, and the pros and cons. So thank you again, Charles, for your excellent presentation. So next week, in 2 weeks, we are going to invite Binyuan back, and he is going to provide a provoking and highly interesting topic regarding how each of us can train large language models like ChatGPT. Is coming true. We provide our own data to train large language models from scratch. So it probably is a dream to many, probably most of us, right? But there are platforms that allow us to train our own large language models. So we'll hear more from Binyuan in 2 weeks. Thank you, everyone, and thank you, Charles, specifically. And we will see each other in 2 weeks on Saturday. Bye, everyone.
Bye, Professor.